Alright guys, you are welcome to my channel once again. So we have before us this is a panel. It's an automation panel which I'm trying to build for an aluminium production machine. So but before building the panel, I want to first of all build it on a, you can see the platform I'm building it on. Then after that I will now transfer it to the main panel. So like I said, this is a panel that controls an aluminium production machine. I will show you the machine and I will also show you how it behaves. So all you have to do is just stay tuned to my channel so that by the time the video of the machine comes out, you'll be able to understand it. I will show you the video of the machine and how it works, and also when I have implemented the panel, I have incorporated it to the machine. But before I go ahead, someone just asked me to explain a star data starter. So we can see this is star data starter. The machine has a motor, a big motor we are going to control. So that's the need of the star data. So we have this is our controller, our PLC. This is a Mitsubishi PLC. So it's what we're going to do the major control on the aluminum machine. So you can see our buttons and the indicator lights. I will give you a detailed explanation on this. So all you have to do, just stay tuned to my channel. I'll give you a detailed video about this. But for now, I just want to do a short explanation of star data connection, the schematic diagram for some of my fellow technicians that are still finding it difficult. So we start from the circuit diagram of a star data connection. So I will show you what we have here. You can see this is the power diagram. This is a power diagram of a star data. It is made up of 3 contactors, just like we have here. You can see the 3 contactors. This is the first contactor, this is the second contactor, and this is the third contactor, and this is a timer. So this contactor, this is the main contactor. We call it main contactor. This one is called the delta contactor, and this is called the star contactor. You can see the size of the star contactor is smaller than the rest of other contactors. The reason is this: when starting a motor on a star, it takes less current. So by so doing, the power consumption is very low. So it makes no sense if you are using a big contactor as your star. It will work, but we are trying to cut down cost. So that's why we go for the star, a smaller rating contactor for the star, which will still work. Alright. So we have our timer. So looking at this, the diagram, the schematic of the star data connection is made up of 2 types of diagrams. We have the power diagram and we have the control diagram. So I'm going to show you the power diagram. You can see this is the power diagram. This is our first contactor, this is the second contactor, and this is a star contactor. You can see how they are being connected. And this is our motor. This is the motor terminal. So you can see we have our red, it can be red, yellow, blue, but here we have red, blue, yellow. It can be anyhow you want it, but you just have to follow it. Make sure it's accordingly. So we have our 3 incoming cable going into the first contactor. You can see the 3 coming cable. You can see this cable, this wire. So that's what you have here. That's what you have here. It goes to the contactor, and the output goes to your motor terminal. It's a star data connection. So in a star data connection, the motor terminal has to be 6 connections. If it is delta or star, you will be dealing with 3 connections. So this is the 3 cable going to the motor side, to the first 3 connections of the motor terminal. Then the other one comes from the delta connection. So you see this connection, see this one, the delta contactor is looped. The input is looped from the input of the main contactor. You can see it here. You see this loop here. You can see it here. This is where it is being looped. This is the looping, so you can see it. You see how it's being looped. You have to be careful not to miss it. Alright, so we will now have our star. We now have our star connection. This is the star connection. You see how it is being looped here. Look at it here. This is how to construct the power diagram of the power of the star delta connection. So the output of the star contactor goes to meet the output of the delta contactor. You can see it. The output of the star contactor goes to meet the output of the delta contactor. So you see, when this is started, when this panel is being started, the delta contactor and the star contactor does not come on at the same time. If eventually it happens, there will be a catastrophic failure. So that's why we now connect the star. You make use of, there's what you call interconnection, an interconnect. So what I mean is that you connect the star through the delta and connect the delta through the star, in the sense that the star will not start except the delta is off, and the delta will not start except the star is off. How do you achieve this? You have the normally closed contact on the star, on the delta contactor. You also have a normally closed contact on the star contactor. So when the star has not been started, the connection to the delta is through the normally closed of the star. You see it. If this star is being started, you have broken the connection to the delta through that normally closed, because when it starts, the normally closed becomes what's normally open. So you see it. So it is an added safety. It's a safety measure, preventing the star and the delta contactor from coming on at the same time. So this all we have for the power connection of the star delta connection. So you can now go to the control diagram. That is where there is a little bit difficulty. So we can see this is it. Yes, this is it. This is a schematic diagram. You can see very well. You can see very well. So look at how it starts. You see this is a single phase circuit breaker. It is a single phase circuit breaker. And which is this? See the single phase circuit breaker. You see it, this is a single phase circuit breaker. So you take a supply. The supply comes in. This is the supply that comes in. You see it. This supply comes in, and it goes to the overload. You know, the overload has to be closed for the control connection to work. If there is a case that the overload is not closed, that means it has tripped. So the motor can cause the overload to trip if the current passing through the motor is above what is being set at the overload. Like this is the overload. You can see an overload here. This overload, and this is the range in which we can set our current rating. This motor is rated, I set it here as 32, and the motor is rated 32. So if eventually the motor draws a current beyond this 32, this overload will trip. Once it trips, it will stop. It will power off the contactors. By so doing, stopping the motor, preventing further high current from going into the motor. All right, let's go straight. Let's go ahead. So I said that the output of the single phase breaker, which is this, goes to the input of the overload. You can see the overload here. This is the input. There are different types of overload. This is a thermal overload. So it goes here. So if this overload has not tripped, it will be continuous to this. It will be continuous to this, which is this one. which is this wire. This is the wire that comes out from the overload, which is this. It goes to the input of the stop button. It goes to the input of the stop button. This is our stop button here. You can see this is our stop button. Okay. Then underneath is where it is connected. I know you know how the under of a stop button looks like. This is a stop button. You can see this is a stop button, and this is how the under looks like. So you connect through one end, and it comes out through the other end. So that is it. So when you press it, it activates. So the output of the stop button goes to the start button. This is the start button, just like I showed you how the under is. So the output of it's just a 2 terminal. The second terminal goes to the input terminal or the first terminal of the start button, and also the output of that stop button goes to the normally open of the main contactor. Normally open of the main contactor. So the output of that stop button goes to this is the normally open of the main contactor. You see it, this wire goes to the normally open of the main contactor and comes out from here. Then from here it goes to the coil of the main contactor. So it goes, you see the coil of the main contactor. You see where it is. So all you just have to do is to follow the diagram to get you to where you are going. Okay, and also the same signal powers the timer, because when the main contactor starts, the timer is also expected to start, to be counting. It counts for some seconds before switching to the delta contactor. I will practicalize this now, so I just see how it switches. Okay, that's all for the main contactor. Then this is the interconnect of between the delta and the start. You can see this is the delta contactor. This is a delta contactor through which we power the star contactor, and this is the star contactor through which we power the delta contactor. Once the delta contactor is off, this is true. It means that the star contactor can start. But if the delta contactor is not off, if it is on, this star contactor can never start, because this place will be open. You can see it is closed, meaning that the delta contactor is off. Same thing applies to the star contactor too. So you can see it. So all you have here is what we have here. So I don't know if you have any question, you can just leave it on my comment section. I will take time and explain further. And if you need a detail of the schematics, if you need the schematic diagram, I will still send it across to you. You just have to leave a question on the comment section. The other one is the indicator light. Usually you have the indicator light to tell you if the motor has started or the motor has not started. So as you can see, when the motor starts, this light will come on, and when the motor is stopped, this light will also come on. Which is this is the light. This is the light for when you press this one, this light will come on, and when you press this one, this light will go off. So if you have any question, just have to leave it on the comment section. Like I say, stay tuned to my channel. I'm going to give you another video that will show a detailed explanation of this panel, the complete diagram. I'm going to show you the video of the machine and how it works. Alright, that's all for now. Thank you. Alright, let's see how the star delta contactor works. Put it on. It's on, then we switch it on. So this light indicates power on, and this red light shows that the control is off. So what do we do now? We have to press start, and for it to start, so we press start. It starts. You can see. You see, it has switched. Like I told you. Watch. Let me stop it. At first start, the main contactor and the start contactor starts. Then after a set time, by this timer, feels like a few seconds, it will stop the start contactor and engage the delta contactor with the main contactor. So let's see. Watch this. You see this one will start. The start contactor, it will start. So watch. You can see it has started. The main and the start contactor started. After a set time, we switch to delta contactor. So like I said, if you have more questions on this, just leave it on the comment section. I will attend to it.